Okay, so we're looking at the iGCSE introductory topic for 5C, part 2, which is specific heat capacity. Um, so what have we got then? Well, specific heat capacity is the energy needed to raise the temperature of 1 kilogram of the substance by 1 degree. It changes depending on the substance due to the internal energy store absorbed in addition to kinetic energy store absorbed. So it's really how does the sort of internal structure of that material work? So some materials, and just skip down past the equations, can take in a lot of energy. So water will take in 4,200 joules for every kilogram for every degree it goes up. So it's actually quite good at absorbing that energy. That actually makes it very useful for heating in houses, because when we've put a lot of energy in, the temperature of the actual water's not gone up by too much, but when we pump it round to the radiators, it can deliver a lot of energy per kilogram moved. Whereas other items, well, a lot of these are metals, but you won't want liquid metal floating around your system, but they're a lot lower. So they get hot very quickly, so like copper, will, and lead. And that's why obviously the melting points are different as well of metals, but it just doesn't work as well. Now, in some situations, that's good. In some, it's bad. You've got to know the definition. We need the formula. So Q, or the change in energy, is M mass C, is the specific heat capacity, times the change in temperature delta T, or you could do T2 take T1. You've got to be really careful with this equation because it's obviously got 4 variables, or you've obviously got this minus bit that has to be taken care of. The other point is, at iGCSE, you don't do latent heat or vaporization and fusion. So just to be careful, you can't do this over a phase change. And if you remember, we talked a bit before about when graphs are flat line, this has to be where the temperature actually changes, and you can't do it over a change in phase. And it's not in the spec to do it either. Practical wise, we need to know about a practical that uses a power pack. So we've got here a power pack, an ammeter to measure the current. We would have a voltmeter to measure the potential difference. And we'd have a timer, so we can do E equals VIT. We can look at the work done heating up a block. Temperature goes up, work goes in. From that, we can work out the specific heat capacity, because the work that's gone in, the energy from the power supply, Q, is the MC delta T. And you know what M is, and then you can work out C because you know what T is from the gradient of the graph, which is pretty cool. So that's one experiment. There are other experiments you can do. So you can either take a hot piece of metal, drop it into cooler water, and again work out temperature difference, or you can take 2 fluids, i.e. water, at different temperatures, put them together, see what the new temperature is, and you can work out using equations the specific heat capacity. So there are 3 possible practicals to know about, and a pretty meaty equation as well. If you need to know any specific heat capacities, they will generally tell you in the questions, but they would expect you to know water at least, and that's similar for chemistry. So there you go, that's 5C part 2, specific heat capacity.